Assalamu alaikum, dear students. So as you know, as a part of this subject, at the end of the semester, you have to submit a group project. And for the group project, you have to choose some real life existing problem and solve that problem using the very simple logic circuit. So in our case, I want to show you some examples. So the first example is a washing machine. So let's say we want to create a logic circuit that will control the functions of the washing machine. Okay, so if you remember, when we create a logic circuit, there's always a relation between the input and the output. So first, let's look at what are the inputs that we have. So first of all, we have a door, right? So in order to start the washing process, you have to make sure that the door of the washing machine is locked, right? So meaning that there is a special sensor, right? Inside the door, there is a special sensor. So this sensor, so let's call it as a door sensor. Door sensor. So this door sensor returns 1 when door is locked, and it returns 0 when door is open or unlocked. Right? So when you, for example, go to the laundromat, right? So when you drop the coin, etc., there's always the first thing you have to make sure is the door is locked, right? So when door is locked, this sensor will return high or 1, and when it's open, it will return 0. The next sensor that we have is water level, right? In order to start the washing process, you have to lock the door, but also you have to make sure that you have enough water inside the washing machine. So this is the water level, meaning there is another sensor here. So this sensor, for example, it will check for the water level. So if the water is above this threshold, right? So if the water is above the threshold, this sensor will return 1. If the water is below the threshold, this sensor will return 0. So let's write these two outputs, these two inputs. So first input is door, we call it D, okay? Another input is a water level, so let's call it L, level. And then the third input is temperature. So let's say you want to wash your clothes at a certain temperature, maybe in a cold water or hot water. So meaning that there is one more sensor here that will check the temperature. So if the temperature is high, if the temperature is at the level that you want, the sensor will return 1. And if the temperature is below the temperature that you set, then the sensor will return 0. So let's say the third input, we will call it the temperature. Okay, so now we have the 3 inputs. What about the outputs? First of all, so since we have these 3 inputs, let's have the matching outputs. So let's say, for example, when we start the washing machine, so when we start the washing process, so that's called is a W, meaning the wash. So when do we start to wash? When we have enough water, right? So when the door is locked, when we have enough water inside the washing machine, and the temperature at the desired temperature. When all these conditions are met, then only we can start the washing process, or the washing machine will start the washing process. Okay, how about, let's say, if the door is locked, okay, but water is below the threshold, so we don't have enough water, right? So if we don't have enough water, meaning that we don't have any temperature yet, okay? So meaning that in this case, the 1 means the door is locked, but we don't have enough water inside, and we don't have the temperature yet, right? So let's consider another output. So this output will control the water level. So we have the valve. So this valve will open and fill up the washing machine. So this valve will go high when we don't have enough water here, right? Okay. Next, let's say we have the door is locked, okay? We have enough water, but we don't have the temperature. So meaning that the door is locked, the washing machine is full, but the temperature is not yet heat up. So we have the third output. Let's call it as a heater. So we have the heater inside the washing machine. So now we're going to turn on the heater. The washing machine will turn on the heater. So heater will go high. Okay? So now in this case, the heater will go high, and we're going to start the heating up the water. And finally, when all the conditions are met, so 1, 1, 1, so this is when the washing process will start. If none of the conditions are met, for example, if all 0, then of course the washing process will be 0. Okay, so let's fill up the missing fields here. Okay, so now you have the truth table for the washing machine. Again, let's say that if the door is open, if there is no water and the temperature is low, the washing machine will not start the washing process. If the door is locked, you have enough water, but the temperature is low, then again the washing will not start, but instead we're going to start the heating. So the water will start the heating up. Let's say you have the door is locked, but you don't have enough water. So in this case, what you're going to do is the washing machine will turn on the valve and start filling up the washing machine. So now we have the truth table. Let's create a circuit. So when you create a circuit, you have to focus each individual output. Don't focus at all. Okay, so just focus at the one individual output first. So let's create a expression for the washing. So when we're going to start the wash? When all the inputs are high. So meaning that when the D is high, when L is high, and when the T is high. Right? So D is equal to 1, L is equal to 1, T is equal to 1. So this is basically we're creating the SOP expression based on the truth table. So this is the truth table here. We ignore the valve and the heater. So this is the truth table, right? So based on this truth table, this portion, we create the SOP expression, and SOP says this, DLT. So when the D is high, L is high, T is high, the wash will be high. Next, when we're going to turn on the valve. Okay, so when we're going to turn on the valve, when D is high, so let's write the valve, equal to, when D is high, but L is low, and T is low. So in this case, we're going to open the valve and start filling up the tank. Another case, this is now for the heater. So when we're going to turn up the heater, when the door is locked, right? So we have to make sure door is locked. We have enough water, but we don't have the temperature yet. Temperature is still low. So T is what? Complement. So T is low. So in this case, we're going to turn on the heater. So now you have the three expressions. Based on this truth table, we created the individual expression for each of these outputs. Okay, so let me zoom in so you can see the better. This is the expression, right? So this is the truth table, and this is the expression that we created right now. Now, okay, let's create the logic circuit now. Okay, so I'm going to erase the truth table because we have the Boolean expressions. So based on this expression, we're going to create the circuit. So for the first case, so first of all, let's define our inputs. So we have three inputs. D, which means the door, L, water level, T is a temperature. Okay, first output is let's start with washing, right? So when we're going to do the washing, when all the inputs are high. So we need, this is just single term, and this is just single AND gate with three inputs. So we're going to just create a one AND gate, and we connect all the inputs here. Okay, so this is a wash. So when we're going to start washing, when the D is high, when the L is high, and when the T is high. Okay. So for example, let's say that if door is locked, we have enough water, but temperature is low. Temperature is low. So in this case, what will happen is the output of the this output will be equal to 1 multiplied by 1 multiplied by 0, and it will be equal to 0. So washing will not start, right? Okay, now let's create the circuit for the second output. Second output is a valve when we want to fill up the water. Okay, again, we have the AND gate, right? So we have the one AND gate, three inputs. So first one is D again. So we're going to connect the D here. So D is connected. Next one is L complement. So meaning that this L will be complemented and then connected, and also the T complement. So meaning the T also will be complemented. So we're going to do the complement here and connect. So T is connected through the complement procedure here. So this is the complement now. Okay. So this is the output for the valve. Okay. Now, last one is heater. So when we're going to turn on the heater? So this is output for the heater. Okay. So when we're going to turn on the heater, when the D is high, so we're going to connect again. This is the D, right? So we're going to connect this one. D is high, so this is coming from the D. Connect here. L is high, so L from here. L is high, but the temperature is low. Okay, so the temperature is low. Okay. Now, in this case, again, we're gonna start the heater. Okay. So this is the circuit. Actually, you can even simplify it more. For example, here we can ignore the value of the T, right? So for the valve to turn on, we don't actually rely on the value of the T. If you, for example, erase this here, just consider the DL complement, that will be sufficient, right? Because the water temperature doesn't matter right now because the water is empty, right? So DL is still low, meaning that we don't have enough water. So in this case, we can actually ignore the temperature here, right? So you can just use this AND gate with 2 inputs. That is okay. Okay. So now this is the circuit. So this circuit now you can create in a Circuitverse. So you can move to the web and create this circuit using the Circuitverse. And also additionally you can add the more features. For example, you can add the timer, right? So you start the washing process, but maybe you want to set up the timer. So you want to put the one more input. So let's say you add the one more input and call it a timer. So how long you want to wash? Maybe 15 minutes or 40 minutes or 1 hour. So if you add the timer, you have to add the extra circuit that will go low once the timer reaches the certain time. Okay, so you have to consider this one as well. Now let's move to the Circuitverse and see how this works in a circuit. Okay, so now we are in a Circuitverse. So let's create the circuit for our project that we created right now, right? Okay, now you can actually start this straight away. You can just the drag and drop the gates and drag and drop the inputs, etc. Or the Circuitverse has a better tool. If you go to the tools and combination analysis, there's a better tool called this combination analysis. What you have to do is you just write down the inputs and the outputs, so it will create a truth table. So you have to fill the truth table and it will create the circuit for you. So now in our case we have the 3 inputs, right? So the first one is door, the second one is water, right? The water level, and third one is temperature. Okay, so let's call this one is level, water level, and next one is water temperature. So these are 3 inputs. And then we have the 3 outputs. First one is, let's say, the wash. Next one is the fill the water. So we're going to turn on the valve, or the heat the water, heater. Okay. Now that this is a truth table, we have to actually fill up the truth table. We have the inputs here, all the possible combinations starting from the 0, 0, 0, all the way until the 1, 1, 1. Now, what we're going to do is we're going to fill up the truth table for the outputs. Look here, when the door is 0, that means the door is open. In this case, we cannot do anything. So whenever door is open, for the first 4 cases, case 1, case 2, case 3, and case 4, right? So let me open the pen. Okay, so for the first 4 cases, okay, so for these cases, when the door is open, we cannot do anything. We cannot wash, we cannot fill up the water, or we cannot turn on the heater. So meaning, in this case, all the outputs will be equal to 0. All of them will be 0. Okay, next, let's say the door is 1, meaning now 1 means the door is locked. Okay, so door is locked, but we don't have the water. Can we start washing? No. So wash will be equal to 0. Now we have to turn on the tap and start filling the washing machine. So this one valve will be equal to 1. Can we start the heater yet? No, we don't, because we don't have enough water. So heater will be equal to 0. Next, same here, right? So door is locked, but we don't have enough water. So what we're gonna do is we're gonna again turn on the valve. So the heater will be 0. Next, we have the door is locked. So door is locked. we have enough water. So valve 1 means that we have the enough water, right? The level 1 means that we have enough water, but the temperature is not what we want to do. So meaning that now we cannot wash yet. We don't have to fill the water because water is full, but we have to turn on the heater here. So the heater will be equal to 1. And finally, door is locked. We have enough water, and also the temperature is high. Now we can start the washing, right? So washing will be equal to 1, and these two will be equal to 0. So now we have the truth table. We just click the generate circuit, and we have our circuit. So, and if you look this circuit, the exactly same as the circuit that we created before on the whiteboard, right? So even if you look the middle AND gate, it has two inputs. The same that we created here, the middle AND gate in our case has two inputs. So now, as you can see, this is logic circuit, a very simple logic circuit for controlling the washing machine, right? So when, for example, when the door is 0, meaning the door is open, no water, no temperature, everything is 0 here, right? Now let's say we lock the door, but we don't have enough water. So what will happen is the valve will turn on. So now the water will start flow inside the washing machine. So let's say that now the water is full, but the temperature is low. So now, as you can see, the heater will turn on. So here you can see the heater. To better see the output, you can actually connect the LEDs. So this is the LED. This is another LED. Another LED. So as you can see now, this LED is on, meaning the heater is on. Okay, so let's say that now we have the door is locked, we have enough water, and temperature is high. Now the washing will start, right? So now washing will go high. Okay, this is a very simple circuit. If you want to, for example, use the same circuit for your group project, then you have to make some very serious improvements. So let's say, for example, you can add the timer. So let's say you want to wash for the certain amount of the time, and then washing will go back to the 0. How to do that? I will just give you the very simple hint. You have to use the counter. For example, this is the counter element. So this counter, it will count up to a certain number. So in this case, what you have to pay attention is how to use the counter. First of all, you just go to the help section. So just click the help and find the counter here. So let's say where is the counter? The elements, standard gates. Anyway, you have to find the counter here. So there should be the counter. I don't see it yet. Sequential elements. Okay, just let me explain how to use the counter. But later you can refer to the help. So this counter, as you can see, it has the two main inputs. This is a maximum value that you want to count up to. And you have to pay attention to the bit widths here. So this is the input bit widths. In this case, the 8 bits. So meaning if you want to connect some input, so this input must be equal to the 8 bits. So if you just directly connect, you see it says the error here, right? So the red color means error. So you have to make sure the input also 8 bits. Okay, so now we have the 8 bits input. Now this counter will count up to the value that you set up here. For example, if you want to count only up to the, let's say 111, right? So now this counter will count only until the until the 111, which is equal to 7, decimal 7. Now the next input is the clock. So let's attach the clock here. So let me connect the clock. Okay, so now it starts the counting. As you can see, it will count until the 7 and then go back to the 0. So 7, go back to 0. Again, 1, 2, 3, 4, 5, etc. When it reaches 7, it will go back to the 0. Okay, so you can actually control how fast to count. For example, right now the clock cycle is 500 milliseconds. You can change it to the 1 second. So 1000 milliseconds will give you the 1 second. So this is now the counting in seconds. 6 seconds, 7 seconds, and then it will go back to the 0. If you increase this number, for example, you can increase it here. Now it will count up to the 11111, which is equal to 256. So this one now will count up to the 256 seconds, right? Okay, now another output here you have to pay attention is this is the output. Okay, so right now let me reduce the number of counters. So let's count only until the 7. Okay, so let's count until the 7. So as you can see, while it's counting, this value is equal to 0, right? When it reaches the 7 maximum number, the value will be equal to 1. As you can see, sorry, when it goes back to 0, the value will be equal to 1. So now you can attach this one to the washing process, and you can actually use this counter to count or how long you want to keep the washing process. I'll not give all the hints, but you got the idea now, right? So you can use the counter. Also, there are so many other elements you can use. For example, you can use the multiplexer and demultiplexer, or the encoder here. For example, you can use the encoder. Encoder, if you remember, we created the encoder during our last lecture. You can use the encoder, for example, to select the different settings for the washing machine. You know that sometimes when you have the washing machine, it has different settings. Wash, or for example, just the dry, etc. Right? So you have at least the 4 or 5 different options. You can use the encoder here, or you can use the encoder or decoder to choose the different option. Okay, so these are just some suggestions if you want to improve on this project. If you want to do the washing machine, try to add some improvements, and make sure that when you create a certain circuit, try not to copy from others. It's okay if you, for example, if I see that some projects, for example, they're implementing the same thing, but of course the implementation must be totally different. If I see that someone is copying from another one, of course this will impact your marks. Okay, so your final mark. Okay, so this is the one example. So in this example, we created a washing machine. We start with from the truth table, from the Boolean expression, and then from Boolean expression we created this circuit here.